In this segment, we're going to discuss tools and safety. Now, when considering safety, we're going to talk about both your personal safety as well as the safety of the equipment that you're working on. Now, with respect to personal safety, the number one thing you can do is unplug any PC that you're working on. Especially, this is important when you're working on older systems. If you have a system which uses the older baby AT motherboard form factor, that system has a power supply which uses a switch that is hot at all times. And when I mean hot, I mean 110 volts AC wall current hot. Looking at this switch here, you're going to see both a blue, a brown, and a black and a white wire. Now, generally, the way this is set up, the blue and brown wires carry 110 volt wall current at all times. When you turn the switch on, the black and white wire also carry 110 volt AC wall current. Now, normally, the leads on this switch will be protected with some sort of an insulator, as you see here. But if this insulator becomes dislodged, such as this, and you touch these leads, you risk electrocution. So these systems should definitely be unplugged all the time or any time that you're working on them. Okay, now for newer systems using an ATX form factor, it's not so much a personal safety issue, but the safety of the equipment that you're working on. In an ATX power supply, the purple lead, which is pin 9 on the connector, is hot at all times. That means anytime the system is plugged in, that lead is hot. Now, it only carries 5 volts, so that doesn't really present a personal danger to your safety. But since the motherboard is partially powered up anytime the system is plugged in, you risk damaging something by installing or removing a card. You could accidentally turn the system on, etc. So basically, for the safety of the equipment in that case, we want to make sure that the system is unplugged. So what this means is, simply stated, any PC that you're working on should be unplugged from the wall while you're working on it. Now, some people in the past have stated that the system should be plugged in order to provide an earth ground as part of the, ESD protection. By ESD, we mean electrostatic discharge. And that's the next thing I want to address. I disagree with that. I think for ESD protection, what you need is the system to be unplugged, but you need to be grounded to the system. Now, there are two ways to do that. I should say there are two pieces of equipment that you're going to use in ESD protection. Number one is a wrist strap. I'm wearing a wrist strap right now. It basically consists of a band, which usually has some sort of a metal inner liner, and then there's a connector with a wire. And then this would normally be clipped to either the system that you're working on or to a mat such as I have here. If you're going to clip it to the system that you're working on, what you'll do is use a clip such as this and actually attach this to the frame or chassis of the machine that you're working on. Now, it should be attached to a metal component, not plastic, and definitely also a surface that's not painted. So some clean, bare metal component on the chassis. Now, the other thing that you're going to use for electrostatic discharge protection is a mat such as this. Now, this is a very slightly conductive mat, and what we do is any components that we take out of the system that we're working on, we want to set on this mat. I, for example, have a motherboard and a video card on the mat right now. That provides a way for any discharge to be vented to ground or to the ground of the circuit board so it doesn't damage any of the components on it. Now, the other end lead from the mat should be plugged into the chassis of the system you're working on also. So in this case, I could use this clip and again attach it to the chassis. So basically, you have yourself, your body, using the wrist strap and the mat, both connected to the chassis of the system that you're working on. And then any components you take out of the system, you're going to set on this mat. And then you, the mat, the system, and any components that are taken out are all at the same electrical potential. Now, by having the system unplugged, some would argue that you're not earth grounded, but that's not important. The only important thing is that when I touch any of these components, that there's going to be no flow of electricity between me and the components on the board, and thus possibly damaging the board. Now, if you're handling boards out of the system, like I have a video card and a motherboard here, you want to handle them by a ground portion of the board first. Like, for example, when I picked up this video card, I picked it up by the metal bracket here, which is attached to the ground plane of the board. And then, of course, you want to minimize touching any of the actual chips or components on the board. So hold it by the ground and then minimize or try not to touch any of the components there. Now, a motherboard such as this, you may not see a bracket that is an easily visible ground, but if you look at any of the connectors on the back of the board, they have metal shields around them, and those are also grounded. So if I just touch that shield portion first on these connectors, then I can pick the board up, and it's usually best to hold a board like this by the edges and minimize touching any of the components on the board. So those are the best ways to handle these kinds of devices, and then anytime you're not handling it, just set it down on the anti-static mat.